Hello everyone, how are you all doing? So today here we are back with a new video on our architecture series, and this is going to be video number 9 on staircase. So staircase seems to be a very difficult topic for beginners, and they struggle to understand the Revit automated staircase system, how exactly it works. And the major problem comes in when they want to have a customized thread as well as staircase depth, because initially how we were taught in our college days, I mean 150 riser, 300 thread. But when we start working as a professional, based on the site conditions, thread depth varies as well as riser depth varies. So how we will be customizing our staircase with respect to that? So whenever you want to customize your staircase with respect to the values that are defined in your project, so for that purpose, where you will go, you will select the stairs, you'll go to edit type properties, and when you come here, you will find this option of calculation rule. So you have to set your defined values here. Okay, so my defined values were 162.5 that I have mentioned for riser, and for thread it was 280 So once you do this, once you define these values, what will happen? Revit will calculate your number of risers and threads based on these values. So when it comes to Revit gives us two options here for the stairs. One option is the editing the stairs, okay, which can be done using create sketch option, and the other method is the by default automated creation of stairs. So when you come in properties tab after selecting staircase, so what you see here the base level has to be defined and then top level has to be defined. So these features remain same as all the generic Revit elements, no matter whether it is wall, column, or anything. This is understandable. Second, here this is different. So now I have set up a customized value for my stairs. I have specified the value as 162.5 because there was a client requirement wherein the thread depth has to be 162.5, and I mean visor has to be 162.5 and thread has to be 280. Okay, so how I have done that? So initially, if I go with some other random staircase, for example, cast in place stairs or else precast stairs, let me go with cast in place stairs. So what I will be doing, as you see here, as I have defined the base level as well as the top level, so Revit by default calculates the number of rises that are required, and here see the number of rises height. I mean the riser height is set to 177.3. This is by default. Based on these two specified values, Revit is calculating the actual riser height that is required. And as it said 22, so if I go on placing, you see here that there is the information given how many number of risers are created just below my cursor, and it says that 12 risers are created. So I can stop here, and then you see here that one flight is already constructed, and when I come here again, there are automated dimensions that helps me to indicate how far I am from the first stairs. And now I will not be focusing on the landing, I will directly press here, and this here you see that location line is there, and when I went on to draw the second flight, I can see that it is clashing. I mean, there has to be an offset of 200 but I can't see that because again I have set the option to center. Okay, so if I set the location line to left, it sets right on top of the first flight. I will go here, and this is how I will be able to maintain the gap between the two flight. And when I go and complete the second flight, it says that 0 number of risers are remaining and 11 risers are created. You can see that right below the automated dimensions, and once I do that, the landing has been created by itself, and this is the staircase that Revit has created based on the calculated value. Okay, so now here there are many options that comes in. For example, you see that this is a soffit and the soffit is pretty smooth, but I don't want this to be a deck soffit. I want this to be a stepped soffit. Okay, in that case, what I will be doing, I will be going in edit type, and let me make this smaller. Okay, so when I go in edit type, you see that, let me make this more smaller again. So you see that there is this run type. So in run type, what happens, all the information about the riser, thread, landing is there. Okay, so what I can do is, if I go inside, it says that underside surface. So this is the underside surface which is set to smooth. If I set this to stepped, what will happen? See what has happened. Again, a stepped soffit has been created, and then what happens is the thread depth, which is 150 starting from here. If I set this to 30, what will happen? See, now that thread depth has gone inside. Sometimes there comes a requirement, I mean, as of now there is no soffit. Sometimes there is a requirement from the client wherein they want a stepped staircase with the soffit inside, and at that time soffit has to be modeled separately. So this is with respect to the construction. And then when you come in thread again, so here you have the option to define the thread depth. As of now this is 50. If you do this 100, what will happen? See, now it's not the soffit or the underside component which is going down, it is the thread. Okay, this is known as the thread of the stair component, and this element is going down. And then I have the option to create a customized thread profile as well as nosing. So now that you see here at the corner, this is a nosing. I have created a stairs with a nosing with a thread profile that I will show you guys. But as of now, here we are there to understand the construction of the stairs as well as threads and risers. So if I select this as slanted, what will happen? Let me make this as 30 for better understanding. See, so now as I have set this to slanted, what will happen? What will happen? Each riser is a bit of in a slant position, and let me turn off that option so that you can see clearly what I meant by slant option. Okay, so now this is the stairs what we have modeled, and if I will use the riser depth, maybe it will be clear. Okay, so we'll go again in the one type which is here, and then in threads let us extend below thread. Okay, so here as well there are options. Okay, so these options are riser to thread connection. So now you see here what it says, extend riser behind thread. So now this is a thread, and now the riser is going up and this is extending behind the thread. So if I do it under thread and if I apply, this thing goes below, and then if I select this option, so this doesn't respond because now there are riser thickness which I have kept, as well as here thread has to be enabled. In that case these options will be valid. But again, let us understand the other stairs which I have created here. I will close this, and you see this, that this is another stairs which I have created, and this has a customized thread depth here, and then there is a customized riser here, and here as well I have created a customized landing. So how all these things are created? So when you go inside, and again when you go in type properties, so you see here that again we went into the one type, and this time I have kept stepped as, I mean underside surface as stepped. And then here what is happening, I have loaded a thread profile, and thickness I have kept it as 30. So this staircase we have created as a finishing model. Okay, so the thickness of this stairs, it will not be this much less. Clear? There is the staircase which is coming from staircase model, but our scope was only to provide a surface above that, I mean a finishing above that. Okay, so now what is this thread profile and what is this riser profile? So if we go here, these are the profiles which I have created. This is the profile for my thread. Okay, so you see here that there is this underside surface which I have created, and this again there will be an element here. So in reality, this such type of profile is provided so that it provides you a better grip. Okay, so when you go inside the model, this is what I am talking about. Okay, this is how the thread profile has been created. Now you see here that this is a nosing which is coming in. So now how that nosing is created? So this is the nosing profile what I have created, and if you see the template, this is a profiles template. Okay, so when you create anything in a profile template, it will appear in the model, and that option, I mean the family that you have created, I'll show you that option. So this is again the profile of the nosing that I have created in a nosing profile template, and this is again a riser. I have given the offset of 30 mm because my thread is of 30 mm, so this is sitting just below my thread, and all these three profiles are defined in here, and this is what is reflecting. So if I go in type properties, you see here that this is a profile which I have loaded, and then the 6 mm dimension that you see here is this one. Okay, so this is the nosing length, and thread thickness is this one, and then I have specified that I want nosing only at the front. What will happen if I select this front as well as left? See, so here you see that this is a nosing that has been created on the left side as well. If I select this front, left and right, again you will see here. Okay, see, so now the nosing has been created on all the sides, but I want only nosing at the front side. If I press OK, a nosing will be coming at the front. Okay, now this is again a thread, and riser thickness will go in this manner, and I have mentioned that it has to extend under riser. Okay, so this is how I have mentioned the connection details within riser, and I have mentioned that extend this thread under riser. That's the reason this thread is sitting on top of the riser. Okay, so now this is about this staircase, and this is about the automated staircase system that Revit gives us. I will select the slant option just to demonstrate what happens. Now exactly this is depending on the profile which I have created. That profile is pretty straight. That's the reason slant option doesn't work. Okay, but I will find a way to demonstrate this as well. So now these are all the important settings, and then yes, there is again connection method. So now you see here end connection. If I want to show you, so this is the end connection. Okay, so you see here that there is the end connection, and in this type of stairs, the end connection has been set to straight. If I set this to notch, what will happen? See, so here, based on the profile that I have created, Revit will not take that option, but this is a stairs where we are not using any profile. So here Revit will demonstrate that connection option here. Okay, so if I show you that connection option, okay, again that option is not there in cast in place, so we will go for precast stairs to understand that. And if I select precast stairs, it gives us error that there is a bit problem with the notch, and end connection has come in here. And see, if I set this to straight, what will happen? So let us delete the stairs, and we'll model the stairs just to understand the end connection. Over there we have changed the default settings, and what we'll do is we'll go to stairs here, and once we'll go to stairs, we'll go to cast in place, and then you go to landing, you create a 12th number of risers here, and then you define these settings. Okay, so what we will do is we will change this depth monolithic. This is coming as 300. I think our step is on how much? 30. We'll keep this as 50. We'll keep this as 50. Okay, I didn't duplicate the stairs. That's a mistake what I did. And here again, we'll go to edit type. And then what we will do is we will keep monolithic material, all these settings as okay, all the settings as 50 on the side. Okay, 50 we will keep it, and we will keep this as smooth. Okay, so now what we will do is we'll go here at this place, and when we go inside, you see the end connection details are there. Again, we have selected the cast in place, so let me just change the stairs, transform the stairs to precast. And this option connection method only comes in precast stairs. So we have changed the settings, because of which Revit is giving us the error. Okay, I can't remember the default settings that were there before, hence all these difficulties are coming. But again, how this landing as well as these flights will meet each other, that is the connection details. If you keep as notch, what will happen is Revit will show you a profile in this manner, that this entire thing is sitting on top of the landing, as this is now. Okay, so if we go to straight cut, this will meet staircase straight. I think I can demonstrate that from this end. Let us see here. Okay, let me just change that option again, and if I set this to notch, what will happen now? Okay, see here. So now this is how Revit is showing you, and there is a flight, and this is meeting with landing in the form of a notch, which is creating a profile similar to that one profile is sitting on the other. But if you keep this to straight cut, what will happen? Again, it looks monolithic. Okay, so this is the connection details. Apart from that, what if you want to change the profile? I mean, what if you want to sketch a landing in a different way? Okay, so you can go to edit stairs, and then you can select the landing, and once you select the landing, there will be the option here of edit sketch. So this is how I have created the landing based on the client requirement. There are other structural model which is coming in, because of which we were told to give the cut here. Okay, so now what if you don't want this dock like the stair, and what if you want a customized stairs in this manner, how I have created? Okay, so in this case, what you will be doing? Okay, so as of now, what you can do is you can go to stairs, and once you go to stairs, you will find the option here, create sketch. So you have to first create a run, and for creating a run, what you have to do, you have to define the boundary. Okay, so now this is the boundary which I am creating, and once I create the boundary, I have the option here to first create the boundary. I will say that this has to be 900 mm. Okay, so we'll move this a bit. Let us keep this as I'll just show first a flight for better understanding. So now what I have done, I have created a boundary here. This is the boundary for the first flight, which will be in this manner. Then I will go in riser, and then I will make sure that my flight starts with a riser and ends with a riser. Okay, and based on this, what I have to do, I have to define the thread thickness here, thread width. Okay, I am saying that this has to be 300 mm. After that, I can simply go on copying these threads, and what will happen, Revit will understand that this is how this flight has to be, a first flight with this as the boundary, and then here there are number of risers which I have created 12, and then I have to define the stair path for Revit to understand that this is where the stair has to go. And if I complete the command, see, based on the number of steps, based on the number of risers I have created, Revit has created such type of stair. Okay, So now if I close this, in a similar manner, what I have done is I have created this stair. Okay, so the concept is pretty simple. That the boundary has to be green in color, and this is where Revit gives you this option. And then the staircase are the riser are indicated with black color. For modeling the riser, you will be selecting this option. And when you model riser, the concept is boundaries has to be the external sides, and inside whatever you will be showing, that will be counted as a riser. Okay, so nowhere inside you see that I have used a boundary. Everywhere there is a riser. Okay, so for modeling this stair, what I did first, I created these two flights first, and then I created this landing separately. Okay, how I created landing separately? Again, when you go out, you see this landing option here, and then Revit gives you the option of sketching. Okay, so this is how I have sketched that landing. Okay, so the concept is pretty simple. The boundaries has to be green in color. When you select the boundary, Revit will model the boundaries green in color. And once you draw the boundary, you need to understand that boundaries are the external sides. Okay, and then riser, a stair flight has to start with a riser, end with a riser, and then you have to define the stair path. Once you define the stair path, what will happen? Revit will understand where exactly your stairs are going. Okay, so this is how I have created this customized stairs. If you want to create a spiral staircase, again Revit gives you that option here when you go in edit stairs. Okay, full step style spiral staircase, and then again there is this option L shape, a window, and then here U shape window, and this is the generic dog leg stair. But all these options are rarely used because most of the time we will be modeling customized steps. So I will be coming up with a video on how to model a steel stairs, as well as there is a different stairs that I will think of creating, which will be more customizable, as well as which will be very different. But again, I have, for demonstration purpose, I have created this stairs just to make sure that your path sketch staircase concept is clear, because you will be spending most of the time on this, not the generic method what Revit gives you. Okay, so again there are railings, but if I cover railings, this video will be very lengthening. Okay, so in that case, I have decided that I will be coming up with a railing video separately. Our next video will be on railing. As of now, this is what I have demonstrated, modeling of stairs. So learners, let me know if there are any difficulties, and as always, let us rise and shine together. Thank you, learners. Thank you.